All right, so we're going to talk a little bit about this practice problem here. Let me share my screen.
You got a mustache haircut.
Say what?
You got a mustache haircut.
You mean I shaved? Yes, I did shave. It's getting a little out of control. So to-char array is a method you can use on string. It can convert your string into a character array, basically. And a character array it's easier to work with when you're doing stuff like this, when you're changing strings around or values around in the string. So basically, same basic for loop. For int I is 0, I is less than characters at length I plus plus. If I mod replace key equals 0, then update characters at I to the X character. And then at the end of the day, we're going to return a new string from our character array. Because they're basically the same thing. Make sense?
Is there anything else to do besides mod?
See, this is a problem because the first one needs to be replaced also. How about if counter is 0? Counter is 0, XX. There we go. See, that's the benefit of using unit tests. So I can refactor that with freedom, knowing that the end result is, I mean, if it's the same, then it works. Right? But yeah, so basically I did the same exact thing, just manually incremented this counter variable. So there's 2 ways of doing that. Okay, so let me go ahead and add that real quick to our repository. Ridiculous internet strikes again. Okay, and now we can talk about our, oops, sorry, our lesson for today. Today we're going to talk about databases. Actually, we're talking about two things today, because I think I've been talking about this for a while. I've been hinting at it, but I finally want to do it here. We're going to talk a little bit about Git and GitHub and what are called branching strategies. And we're also going to talk about databases today. So a little bit of extra stuff tacked on to today, but it really directly impacts how we make submissions or assignment submissions. So I kind of want to talk about it right now, okay? So let's go to GitHub. The cool thing about GitHub is that, you know, it lets you collaborate really well with a bunch of other people. Git in general is designed for distributed, you know, programming. You know, thousands of people can contribute to the same repo. Pretty rarely it's in the order of thousands, but it does happen. Like Linux, there's over 1,000 contributors to Linux. And I'm pretty sure all of the Linux source code, by the way, is on GitHub, which is pretty cool. So what we're going to do here is I actually own what's called a TIY Charlotte. I own an organization called TIY Charlotte Java, right? So in here, you'll see a lot of stubbed out projects. I'm going to make one in just a second. But typically how you would interact with an open source repository is that you would fork the repository, do your work, and then submit what's called a pull request, okay? Now this is a GitHub specific feature. It's not specific to Git, but it's the common pattern that is used by almost all developers if they work with GitHub, okay? So here's what I want to see, guys. So I'm going to make a new repository now. I'm going to call it SQL Homework. Okay, so we're going to initialize this with a README and create the repository. So now, what I want you to do for homework is to, instead of making a new repository from scratch, is to fork this repository. You can do so by clicking this fork button up here. You hover over it, it says fork your own copy of the TIY Charlotte Java SQL Homework to your account. Boom. If I fork it, I can fork it to my personal account, and it's going to fork it. There's a little copy with a fork in the book. Very clever. GitHub's awesome like that. So this is what you'll clone. Okay? So you'll clone your own repository locally. Got it? So say I do some work like create a new file called test.md, and it says, hey, I added some things. Here are some things. Okay, so let's save it. Make it a message like adding test file. Okay, so there we go. We have test.md there. All right. So you can see, since we have forked this repository, you see this little gray area above the blue area here. It says pull request or compare. We can compare it and we can see the differences between this repository and the one we cloned it from, the forked it from, right? You see it's just one file, test.md, and it says here are some things, blah, 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 blah. All right. So you can do this, you can create a pull request here by clicking this button here. Create pull request. So it'll show you the comparison. It compares these two things. So it says base fork is where you from, and it's the master branch of that repository. And this is the master branch of my repository. And we create a pull request. So in create a pull request, we'll talk about like the change we made. So in a normal project, you would talk about in here the reason why you made these changes and what you saw in the project needed to be fixed, right? So you'd be like, I thought you could use some more useless markdown files. So I added one, right? So that's the thing. You say click create pull request. The internet is slow and almost dies and probably does die. And you have to wait for it to start up again. Okay, so we made a pull request. You see it's an open pull request. So see now we're actually not in our repository anymore. We're in the TIY Charlotte Java organization's repository. So you can see here, this is the repository. There's one pull request now. And I'm gonna open this up. I'm gonna see this adding test file pull request. I'm gonna click on it. And then I can actually go and look through all your commit history and the files that you changed. And I can comment individually on everything. I'm like, why would you think this is a good idea? And then comment on it. You can see kind of my feedback in line with all your code. This feature exists in TIO, but it's not, you're not going to be using TIO when you get to a job. So this is more streamlined what you're actually going to be expecting in the position.
What did you put in order to get to that screen to the edit?
I just went to pull requests. I just like this is a list of all the pull requests right now for this repository. Right now it's just this one. Yeah, just click that. So I can see like this is a timeline of events. So I made this comment and then this is the commit actually. That's tied to that comment, right? And then after I did that, I commented on the diff. Like I went to the line number that the change pointed out, and I commented on it. It's like, why do you think this is a good idea? So that you can see it's like a timeline of events. This is the window. It's a timeline of things that happen. And if I close it, you can see it's going to get closed or reopened or whatever. It's all going to show up right here, right? So basically, right here, it's going to tell me, it says this branch has no conflicts with the base branch, and the merging can be performed automatically. And normally, what would happen is you'd, as a developer, the person who owns the repository, if you think it's a good pull request, you want to merge it with your code, you click merge pull request, and then you confirm the merge. And then, yeah, that's it.
So are you going to be giving us like a base project?
Yes. It's not going to be anything. It's going to be nothing, basically.
Yeah.
It's just going to be a shell of a project. It won't even be, like, a lot of times it'll just be a README with, like, the assignment description. It's not even going to be anything else.
So our bosses, who are senior developers, would be accepting and merging pull requests
Yes.
for the code that we write.
Yeah. Actually, a lot of times it will be your senior lead developer on a project. Other times they will assign you as the owner of, they will assign other developers to accept pull requests, right? Generally, how it works is that you are not the person who approves your own code. So it is not necessarily your boss that tells you, yes, this is good, or no, this is bad. It could be your colleagues. So if I'm working in a team of maybe 5 developers, and I make a change and I push it to a remote branch, and I submit a pull request, I'll assign another developer on my team. He's not my superior. I'm not his superior. I'll just assign somebody else to take a look at it and give me feedback on the branch, and they can be responsible for, merging it or adding comments to it. In that way, it's kind of an automatic way to share knowledge. So a lot of the best dev shops out there follow this pattern, where you basically are learning from one another. It's pretty cool. Not everyone does this, but everyone aspires to this. So if you tell someone that, this is the way you typically work, or, that this is the pattern you usually follow, their ears will perk up. Be like, okay, that's how I should be doing things. Yeah. So one last thing I want you to do, and I'm going to be keeping an eye out for in the future assignment submissions. It's also something called feature branches. Okay, so far we haven't been working with branches at all. We've just been like, we have our local master branch and we have our remote master branch, and we just like, here's some changes, push to the remote branch, and we're all happy, right? But the problem is that when you submit a pull request, it's tied to your branch name. So if you made your changes on master and you push the changes to your remote master branch, and then you submitted a pull request to your originating repository, if he's going to accept your pull request, he's going to have to accept that inside his master branch, because that's the name of your branch, right? So that's not an ideal workflow, because he might have master be like old stuff, right? And like all your new dev work might be on like dev branch, okay? So typically what happens is if you work on a feature in Git, you'll make a branch for that feature, right? So like the first step in a lot of development is to git checkout-b feature name. Like if you want to add a database to your project, you like adding database, and that's a branch. And you push that to a remote, and then you submit a pull request with that remote branch name. So when he accepts it, that branch will get added to his project, and then at his discretion, he can apply that he can merge that to any other branch. Like if it's like an in development branch, he can merge it in there like that. So I think I should go over a couple of examples of what I'm talking about here. And so when we do our in-class assignment here, we'll kind of periodically, it's not, the lesson isn't designed for me to be doing that, so hopefully it'll all pan out, but it should be fine. But I would like for you guys to kind of keep this in mind, this branching strategy approach, when we make assignments in the future, or when we submit assignments. Like I said, it's very close to what you'll see in a workplace environment. Cool. So one other cool thing is that you can actually, there are many features of GitHub that we haven't touched yet. And you can see them here. I mean, there's a Wikipedia area for each repository. Like if you wanted to add documentation for your project, which is highly recommended. Like if you make a Java doc, you could link to it from here, or if you have a developer getting started series of steps that they need to take, you would put it here in the wiki. Or if you have like a branching strategy that you want your contributors to follow, you put it here also. So the branching strategy we're going to take, and by the way, that's when we make a new branch for our feature, it's called a feature branch, but that's a kind of a branching strategy, and they get really complicated. But we're going to start out with the basic one, which is just make a feature branch and merge it back in with master when you're done. Okay. So your own company is going to have its own branching strategy that you'll have to abide by when you submit code, if they use Git, which hopefully they do. This all may seem a bit much, but we'll look into it in a second. I'm confident that it'll start being clear. Okay. But we also have issues are a part of GitHub. So an issue is a way that developers can tell you if there's something wrong with your code, or they can submit new feature requests through issues as well. So if we take a look at this, we can actually go here. GitHub Linux. Yeah, this is Linus Torvalds' GitHub account. He has Linux as one of his repositories. There are 106 current pull requests. Did he disabled the issues tab? Wow. I guess you can disable it because there's no issues here. Usually you see a list of issues, but I guess Linus decided that he was going to handle his issues in another way. Look at this, there's an infinity sign contributors here. Wow. Anyways, Linux is a pretty big thing. Let's just go to Linus's page. This is GitHub activity, by the way. It's freaking ridiculous. Here we go. Nope, not even that. All right, I'm giving up on you, Linus. Maybe some other random guy, like this guy. Here we go. So here's a random repository by some random guy. I'm not even sure what it's doing here, but basically you can see that here's a list of issues. He only has one. So someone randomly commented on his to say that, you know, the tarball extracts files into the current directory, right? Some random thing that your code does that shouldn't be happening. And then so as the author, he can comment on this and say, hey, it should be doing that, or oops, that's a problem. And then like he can assign, this is a issue number 5 on this repository. So in his commit log, he can reference number sign 5. It's like this is related to issue number 5 in his commit message, and then GitHub will link the two together for you. So you can kind of see your issues and the commits that have gone to address the issues simultaneously. So like if you made a commit and it referenced this issue, you would see it in this issue list, and so you could close the issue. So anyone coming back and seeing the repository can look at this closed issue and see like the correspondence between the author and the person who submitted it, and they can see the code change that the author used to fix it, and then, you know, everyone's happy, right? It's like full documentation. Okay. But apparently, and I've never seen this before, just now with Linus, you can disable the issues tab, which I'm guessing he's doing because he's delegating issues to another system. But yeah. It's crazy to think that all of Linux is here. But this guy wrote Git, and he wrote Linux, and now he stores Linux on Git on a website dedicated to Git. It's pretty crazy.
This is the kernel. It's not like a full distribution.
Right. But there is, I think Arch is here.
Yeah.
So like our Arch Linux is a distro.
No, that's Arch, like architectures, like
Oh, you think
different files for ARM, x86.
Oh, really?
Yeah. This is like, I did this every day at my old job.
Really?
Yeah.
Nice. Cool. Anywho's, so that's one thing. Now we're going to learn about SQL. So we're going to start our discussion on SQL as to why we want to use databases, right? So when we first started writing applications, like web applications, for instance, it was all in memory, right? So every time you restarted your server, all of your users were just gone, right? They weren't there anymore. Because those objects existed in memory, and when you restarted your process, then they got dumped along with the rest of your program, right? So there's nothing to persist that data anywhere. So then we added file I/O, right? So when you add a new user to your user's hash map, for instance, you wouldn't just add it to the hash map, you'd also just write the serialized hash map to a file somewhere, right? And every time you update that hash map, you would write to the file, okay? But that's kind of a problem because first of all, it doesn't scale very well. So if you don't just have one user, think if you had that file writing system for like maybe 1,000 users. So you have, and in the web world, you have to not only consider the size of the file, but you also have to consider concurrency issues. So 2 people could be hitting the website at exactly the same time. You have to consider that when you make your websites. And if you have a file that's being opened for writing by one guy and another guy comes in to try to write to that same file, then if they write in the wrong order, then they could screw all your data up. Plus, imagine if there were no persistence on the web and like a server experienced an outage. Like, for instance, like if you were a Reddit user, right? Or Facebook user, and like Facebook went down for not even like if one of the servers in Facebook crashed and they didn't persist any user information, then after the server came back online, it would have no information about any user. Basically, Facebook would be empty, right? So obviously that's unacceptable. Okay. So databases exist as a way to store data. Relational databases exist to store data efficiently. So they're called relational databases because they relate information to each other. Right? And we'll kind of see what that looks like in a second. We're going to see like tables and how they map to other tables and stuff like that. But in a nutshell, they allow you to update data quickly and efficiently, right? And you don't have to like write to an individual file over and over and over again, because that's actually really slow and time-consuming and inefficient. So for now, you could think of a database table like an Excel spreadsheet, right? It has columns, it has rows, and the columns have meaning, and then just each row is an entry in that spreadsheet. So how you interact with a SQL server is through SQL, right? SQL stands for Structured Query Language. It's designed to be human readable, like kind of like English. But it's kind of like, since they've designed it, they've added a lot of things to it that have made it not so readable, but that's still its goal, right? So here are some basic commands. I mean, we're talking about CRUD, create, read, update, and delete here. So you have create table, which is how you make a new table. Like if you want to store puppies, you create a table that has columns in it for each value that your puppy should have, like, I don't know, breed and sex and, I don't know, age, right? Or vaccinations list or something like that. So insert is a SQL command that corresponds to how you actually add a puppy to the table, right? So you like insert into puppies. This, I'll go over examples in a second. Select is how you retrieve information from a database. So if you run a select query, what you get back is the puppy data, right? And you have update and delete. So update is you have puppy data already, we're gonna update it. And delete is remove this row from our puppies table, right? So in Excel, there is no restrictions on the type of data that can go into each column. Okay, like you could put in one column, you could put a number, you could put a word or a phrase, you could put anything in each column. But in databases, that's a little bit different. So for a given column in a table, you have to have one specific type of information. Like here are very common types of information. You have varchar, which is basically a string in the SQL world. You have booleans, ints, and doubles, right? And those are direct mappings to what exists in Java, right? You have true and false, you have a number, a whole number, and you have double, which is a decimal-based value. So basically, let's see. For example, say we want to make a table that stores players in a game. We want to keep track of the player's name, whether or not they're alive, their score, and their health. So we have their name would be a varchar. Alive would be a boolean. These are individual columns. So each row would represent a player, and the column would represent the data for that specific player, right? So string varchar, or name varchar rather, boolean is alive, int score, and int health, or double health, right? So you can see that kind of in your mind, like an Excel spreadsheet with those columns bolded and those values that exist for each one for each user. Okay. So frequently, people like to write SQL in all caps. It's not strictly required, but it is convention. So here's an example of a create table statement. You have create table players, name, varchar, is alive, booleans, or int health done. Right? So these are the specifiers for the columns here, and this is just specifying they're going to use a create table query. Jennifer, do you have experience? Does this look familiar? Okay. So once players exists right here, after we run this query, we can run this insert statement. So you have insert into players values Bob, true, 0, 100. Note that these map up to these guys, these columns. So after this is run, we have one player in our players table that has those values. Okay? So when we retrieve the information in Java, we'll basically make an object that represents that data. So here's an example of a where statement. So these are very powerful SQL conditional statements that are a little bit different than what we experienced before. So update players set is alive false or name is Bob. So you can kind of see what SQL's going for with the readability thing here. In English, you can kind of abstract this away from the SQL. Like where the name is Bob, or the player's name is Bob, then they're alive, right? Set them to alive, right? But the problem with this is that what if you have like a large database of people, of players, and you have more than one Bob? You can't just say, if you're missing this where clause, for instance, and this update becomes update player set is alive false. That murders everyone in the game, right? Which is clearly bad, right? So you say where name is Bob. This is a little bit better because we're only killing all the Bobs. But ideally, what you have here is a unique identifier for Bob to say that this is the specific Bob we're talking about. And we'll get into that in a second. But the where clause limits your updates or your selects to a subset of information. So if you want to get all the information, all the people whose names are Ben, you'd run, well, we have a where clause here, right? So select star from players where name is Bob. So it's just gloss over that, it went straight to the update there. So this select star from players where name is Bob. This where statement restricts this select to just the people whose names are Bob, right? And the star is actually indicative of the columns that you want to return back. So frequently, people run queries like this, select star from players, their name equals Bob. And then because they run this query so frequently, they think that the queries that you run in SQL have to map to tables, columns. This is going to give you all the columns from the players table. But SQL is much more powerful than that. You can select a subset of columns from the players table, and you replace the star, which is a comma-separated list of column names. Like if you want to get their name and their ID, you got a haircut. What's your? Oh man. Your hair. Thanks. So down here at the bottom, again, the where clause is very important. Because you're not just murdering the players here if you forget the where clause, you're deleting them from existence entirely. Right? So if you run the delete from players, then you have a problem on your hands. Right? You're deleting everybody. Cool? All right. So let's start our in-class work. I'm gonna make a new project. Java project. Hello database. Not in student submissions. Code. All right. We're going to add what's called the H2 database to the project from Maven. So H2 is an example of a in-memory database system. It's a pretty lightweight database engine. There's ones that exist. You may have heard of them. MySQL is one of them. Postgres is another one. Oracle has an offering as well. It's expensive. SQL Server is what Microsoft uses. There's other ones called NoSQL databases, which are very different. There's other database systems that take a different approach to storing data. There's like Mongo, and there's one called CouchDB. There's another one called React, which is extremely amazing. Anyway, there's a lot of options when it comes to storing data. There's not one right way to do it. We're just going to focus on using H2 for now because it's actually pretty straightforward and simple to use. So we're going to stick to H2 right now because it's, again, really simple. Like usually these SQL Server systems, they require you to have like a running process on your computer, and you have to like manage them separately. It's kind of a pain. You know, just to get up and running with SQL, we'll just use H2 for now. Okay. Other cool thing about H2 is it gives you this class, this server class that has methods called create web server. SQL exception. So this method is actually going to start a new web server and then open up a browser that you can use to navigate to that web server. So let's run this. So we'll go here to localhost 8082. So this is the web interface to our running H2 server, okay? So our main code started up a server, and that server accepts connections on port 8082, and it presents you this web interface, okay? So we're going to change this field called JDBC URL to this, which it looks like it's already there. So we're going to keep our username and password blank and just going to hit enter. Yeah. So we're in this kind of database view of things, right? So H2 is a concept called users. We don't really have a user yet. We just have admin. This is an internal H2 folder. For right now, we don't see any custom databases or tables that we made ourselves, right? So let's go back up here and we'll do a create players table. We'll create a table called players here. But we're also going to have another column in the beginning here called ID. And the type of column this is an identity column. All right. So an identity column is one that represents this row uniquely. It's the identity for this row. So every time you make a new player in this players table, it's going to have a unique player ID. So that's how you can identify that one row individually, guaranteeing you won't ever select another row. So if you select everything where your name is Bob, you're not guaranteed to have one thing come back. But if you select players where the ID is 4, for instance, it's going to give you one result, and that result's going to be wherever you expect it, right? So it's important in database design to always have an identity column, right? We'll go ahead and run this against our database. So ever since we ran that, over here on the left-hand side, we see a players table on the left. So we have ID, name, is alive, score, and health, right? So those columns exist now. So now that the table exists, we can actually run SQL queries against it. The first thing we're going to do is we're going to insert a new player called Bob. Let's go back up here and copy this insert query. So insert into players values Bob true 0 100. Now, since we created this SQL query, we added a ID column. So the thing is, you don't tell the database system what your ID column is. You're not like, I want to make a new player with ID 5. The database will generally give you that ID column value. So when you insert it, it'll automatically add the identity to your row. So we run it. It says update count as 1, which means we updated 1 row in our table.
So sorry, when you did the create table, you just cleared it?
I just deleted that SQL.
Oh.
Yeah.
And it stored it?
Yeah.
Or you delete it?
When you remove the SQL, I mean, this box here is just for you to run SQL queries. So it's like a command. It's like, hey, SQL engine, create this table, and then after you run it, you don't need that SQL anymore. It's the table exists.
Oh.
Yeah.
So you just create, delete, and it stores it.
Yeah. Well, it's important to note that after I typed this text into this box, I hit run, so it executed this query against the database engine, and then the database engine created a table called players based off of the query. It's like messages you're sending to the database engine. So the message I sent in this case is I want to add a player with these values into the players table. Okay. So next we can run this select query.
Sorry, so if you hit the run button multiple times, will it store multiple bits?
It can, yeah. If with the create table one, actually any subsequent table already exists.
What about the rest of the commands? Like this one?
With select, you can run it as many times as you want. Okay. So we have inserts, we have selects. See here we have in our screenshot, select star from players where ID equals 1 instead of where name is Bob. If there's only one row, then that makes, the end result is exactly the same. But if there were tons of people, like hundreds of thousands of people, then there's a big difference, right? So here's an example of update. So it's update players set is alive equal to false, run. Let's start from players, say is alive is false. And remember that if you update a table and you don't specify who to update, it's going to update everybody. So in this case, I murdered everyone in my players table. Thanks. And then finally, you can delete stuff from your database. So delete from players where ID equals 1. Run. And select star from players, returns no columns. Or no rows, rather. Because there's no people anymore, because we eliminated them. So,
How do you delete the whole database? Or the whole table? Sorry, not database.
there's a SQL command called drop table. There's create table, and there's also drop table. So it would be drop table players. So we could do that. Drop table players. Run. You can see up here on the left that table doesn't exist anymore. Like right there, players is gone completely. So I'm gonna re-add it real quick. Oops, nope. There we go. So we have to be able to run these commands in code, right? Because otherwise, what are we doing? Because our whole goal is to learn how to update this stuff inside Java. So if we had to go inside this interface every time we wanted to run something, then that would be a problem. We have to be able to do it through our websites, right? So subsequently, that has to happen in Java. Okay. So the first thing you do is you get a database connection string here. So you'll note that when we booted up our web server and we connected to a URL, we connected to this URL here, right? So by default, this is the connection string for the database that specifies the current H2 database. So to break this down a little bit, so you have JDBC is Java Database Connection, separated by a colon and H2. This is the kind of database we're connecting to. And then another colon and then /main will basically store the database in a file called like main.db in a relative path with respect to where you stored or where you ran your application. Okay. So Driver Manager is a part of the Java SQL package. It basically just manages connections to SQL databases and has a get connection method that takes in the connection string. And at the end of the day, you have a connection object, which allows you to run queries against the database.